So, section 1.6, the title says multiplying and dividing real numbers. Now remember, a real number can be anything. It could be a fraction, it could be a decimal, it could be an integer, anything like that. So, all right, so let's take a look at this. I guess you flip to 1/6, put that away for right now. We got our 3 new properties at the top. Now we have to add these to our other 2 that we already have done. The first one says identity property of multiplication. If you remember here, Dylan, if it says identity, that basically means the number doesn't change. Now I need to teach you a new little symbol here. Have you ever seen a little triangle like that? That's an abbreviation in math language for change. It's a Greek symbol that means delta. It's a delta, and it's a letter in the Greek alphabet, and it means change. So you will often see me use the delta symbol instead of the word change, just for an abbreviation. So here's our example. 5 times 1 equals 5. Start with a 5, you end with the 5. The reason is the identity property of multiplication. Then, you all know when you multiply by 0, you get 0. True? At some point, someone had to say and define that, because it had to be kind of defined as this is the rules, this is the theorem that we're going to go under, and make it from there. So that's just the multiplication property of 0, very straightforward. And then we have the inverse property. We've already had the additive inverse property back from section 2, I think. This is the multiplication inverse property. Fancy word, it's called multiplicative. Now, are you familiar with the fact in the word reciprocal? Reciprocal means like the reciprocal of 2/3 is 3/2.
3/2.
Or 3/2. When you multiply reciprocals times each other, you get 1. Now why is that? Let's look at this. 3/2 times 2/3. Why does that equal 1? Well, 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1. So as we're looking at our multiplicative inverse rule, our multiplicative inverse property, the normal word for that is reciprocals. The fancy word for that is multiplicative inverse. I want you to know both. So if I say, what other word is associated with multiplicative inverse, you're going to say what? Reciprocal. What other word is associated with reciprocal, you're going to say multiplicative inverse. They need to be interchangeable in your vocabulary. So that might be a question that I asked you just as a review. Which word is associated with this word, etc., etc. All right, third one. Division by a fraction. Are you, I hope, aware that when you divide by a fraction, you can rewrite it as multiplying by the reciprocal? Is that a new idea or an old idea? Okay. Have you ever seen your fractions written like that, with a big fraction over a fraction? Okay? So that could be written like that. So instead we say, no, it's not 2/3. So it's 2/3 times 5/4. Now we go ahead and multiply it through. We get 10/12. And do you think we want to leave our answer that way?
5.
Okay, we're always going to simplify to the lowest common denominator. All right? Now, in these capacities, your calculator can do all this for you. But I want you to be doing this mentally and on paper. And I don't want you to be sticking to your calculator and letting it become a crutch. So, all right, down at the bottom, some simple questions. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a, careful, a negative times a positive, look at the screen, is a negative. Now, last but not least. Everybody stand up. When I say stand up, I mean like stand up. On your chairs. Cool. Yeah. Gotta get up. Gotta get up. Come on, Andrew, be tall. Say it with me. A negative times a negative is a positive. Not nearly loud enough. Jocelyn, make sure Andrew is really loud. A negative times a negative is a positive. Okay, they can't hear you in the warrior dome. All together at once. Here we go. A negative times a negative a negative is a positive. Now, don't forget that. It's higher math. All right, don't fall when you get down. You have to get down, yes. All right, so a negative times a negative is a positive. Don't forget that very simple concept. I need to emphasize, though, a little piece. Let's say x equals negative 1. And the problem looks like this. The opposite of x plus 5. You're going to, on your homework, Pat, copy down the opposite of x plus 5 on the first line. Some of you are jumping right to the stick-in part, the evaluate part. In line 2, you're going to go like this. The opposite of parentheses plus 5. Now you evaluate. Now you stick it in. And now we stick in that negative 1. And now you can see a negative times a negative. There's your positive. I realize that many of you can do much of that in your head, but later when the problems get more complicated, I need you to be in the habit of using parentheses to save you from making errors. Question, Al?
Our math teacher taught us, Mr. Morgan. He said that, like, if there's two guys and they both have guns and they shoot each other, and they're both negative, then it becomes a positive situation because they're both, like, they don't have their guns anymore because they're both dead.
Okay.
And then he said if it's, like, one guy has a gun and one doesn't, then that's a negative situation because...
Yes, that would definitely be a negative. I would rather have the two positives where neither has guns. That would be my preference. That is a good way. That is a good way. All right? Commit to me to use those parentheses. It will bail you out. I promise. I tell you experientially. I've been teaching this class for way too long, and I've seen people, when they make a mistake, that is where they make it. And I beg you, and it seems like I'm being a really hard guy on this, and if I am, I'm sorry, but this is where I see people make the mistakes. So please, 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 please use your parentheses. Andrew, you had a question?
I was just going to say, I have something similar. That's like if a bad thing happens to a good guy, or a negative thing happens to a positive, it's a bad thing. If a good thing happens to a negative or a bad guy, it's like a bad thing.
Yeah.
If a negative happens to a negative, it's good.
So very good similarities there. All right, flip her over. Let's look at some applications. One of the problems on the back side is part of the final assessment that we will have this semester in December. One of those is on the final, and I'm going to actually tell you where it is when we get to it. But let's start here. A negative times a negative is a, everyone? What was that? A negative times a negative is a positive. So I want you to physically put a plus. Without a calculator, what's 9 times 5? 45. 45. Second part. Really bad typeset here. That's 2/5, and that's a 6. All right. When you have a whole number, Aiden, times a fraction, the easiest way to think about this is to rewrite both as fractions. Write the whole number as 6 over 1. And physically do it. Write it as 6 over 1, or whatever it is, over 1. Now, can you cancel anywhere? Does anything at the top cancel with anything in the bottom? No. So if it doesn't cancel, multiply straight across. So my answer looks to be 12 over 5. Pause for a second about proper notation. What notation is that called? Starts with an I. Improper fraction. Thanks, Jim. So is it okay to have improper fraction? Yes. You may give me an answer in one of 3 forms, Todd. Improper fraction, mixed number, or a decimal. Please don't fall prey to the student who I wrote down this as an answer. Sorry, 2 and 2/5. They had that as an answer on the multiple choice test, and they didn't choose either one. They worked it out and got this. That was on the answer key, and they didn't realize it was the same thing. So you need to be comfortable enough to be interchangeable back and forth. But in general, I am perfectly fine if you leave your answer as 12 over 5. Or 2.4. Either one.
It's negative.
Yeah, it's negative.
Is it?
Yeah.
The 2 is a negative.
Is it? Oh, is that fraction bar a negative? Okay. Your eyes are better than mine. Thank you. 2 eyes are better than 1, I would say. All right, moving down. It says evaluate the following if A equals negative 2 and B equals negative 10. So here we go. We're going to go parentheses, negative 2 and negative 10. This brings up the second major point. How many negatives do we have total? Sorry, it's off the screen. How many negatives do we have total?
3.
We have 3. So, if you have an even number of negatives, it's positive. If you have an odd number of negatives, it's negative. Because we can take 2 of these negatives and do what? Cancel them out. Okay? So that ends up then with 3 negatives. Those 2 cancel. We're left with 2 times negative 10, which is negative 20. So you just got to pay attention to all the little caveats today. Next one. Who can read that to me? Number 4. It's kind of a trick question. But feel free to give it a try. Emily. Negative 3 to the second power. And what is negative 3 to the second power? What do you think it is? Thoughts? Kristen? What?
9.
I think it's 9. Would we all agree that negative 3 to the second power is 9? I agree that negative 3 to the second power is 9. However, number 4 does not say negative 3 to the second power is 9. Do you remember? Please excuse my dear Aunt Sally and PEMDAS. We all remember that? Okay? Rachel, if you remember, the P stood for parentheses, right? What did the E stand for? Exponents. Okay. We've got to remember this here because it's crucial. You see that too? That's a what? That's an exponent. You see this minus sign right there? That actually is the opposite. This really means negative 1 times 3 squared. And you read that the opposite of 3 squared. That's how that's correctly read. And I have yet to have a student read that correctly because this is one of the first times that this is introduced to you. Look at number 5. What's in parentheses? Negative 3. Now you have negative 3 squared. That's different. What's 3 squared back to number 4? 3 squared. What is it? 9. What's negative 1 times 9? Negative 9. But what's negative 3 squared? What's negative 3 times negative 3? Now, you can see the double negatives, and you can see it's positive 9. So we need to be very careful here. And Dylan, I will come back to this, and back to this, and back to this, and make sure that we're good on it. I want to make sure you make sure that you don't make a mistake on it, Sarah and Nate and everybody here. So, if it's in parentheses and squared, it becomes positive, Hannah. But if it's not in parentheses, that's an opposite sign out front, and it doesn't become a positive. All right, so with that in mind, look at number 6. Where's the opposite sign? It's outside. So what will your answer be? A negative. Now, how do you square a fraction? Put a little note here that says square the top and the bottom. We call these things notes. Who are we writing them to? Ourselves. So what's 2 squared? 4. What's 3 squared? 9. So my answer is negative 4 ninths. Did we talk in here about where it's appropriate to put our negative signs? 2 places. Where are they, Emily? Up
Beside the fraction.
or beside the fraction. Where may you not put it? Down below. All right, number 7. I have a fraction divided by a fraction. Do you remember what to do? 4/5 times the reciprocal? What's the reciprocal of 8/15? Dylan?
15/3.
Good. All right, Dylan, can you talk me through it? Go from there.
It's 12.
You sure can.
The 4 and the 8.
Well, the 4 and the 8 become a 1 and a 2.
And then 1 and 2.
Okay. Everything's canceled now, so what's my answer?
1 and 1 half.
1 1/2 or 3/2. Now, little caveat here. Who likes to write small in their notes? Anybody? When you write a fraction, I want you to use 2 lines. Because when we're doing fraction stuff and then we're canceling fractions, often we need that extra space above and below. And if we try to write too much on one line, your cross-outs and your other things that are written are very, very small. So whenever you do a fraction on your homework, use 2 lines. That'll hopefully help you and protect you from making errors. All right, a different way to write it. I got 4/3 divided by -2/3. How do I rewrite this? Allison, take it for me. Okay. Which do you flip? Yeah, always the second one. Now I'm going to put the negative in the bottom right now. I know it's wrong, but I'm going to put it there. Does anything cancel? The 3s, okay. What do they cancel to? 1s. What about the 2 and the 4? Here's the common error. And people write that as the answer. What did they miss? The negative. So pay attention to that negative. Don't forget it. Don't drop it. That's the common error. And what I'm trying to do here is show you all the kinds of problems that typically slip people up. Just so we hit each one and talk about each one. All right. Number 9 is kind of a big one. It combines all the ideas we've done so far. Before we flip the bottom, we need to kind of simplify the bottom. So I have -1/6 over. Do you remember what you do with the whole number in front? Dylan, what do we do? Okay. We have to understand what is the difference between this and this. This is 3 2/5, which is 17/5. Sorry, you can't see that. This is 3 times 2/5. You see the difference? So here we're going to say 3/1. And now multiply straight across, and what do you get? 6/5. You see the difference there, Dylan? And that's why I wrote that one, because I want to emphasize that one point that you just brought up. All right, now, dividing by a fraction, what's the other word for multiplicative inverse? Reciprocal. So, dividing by a fraction means we multiply by the reciprocal, -1/6 times 5/6. Do the 6's cancel? No. What's my answer? -5/36. What some people do is they don't multiply the 2 6's for some reason. I'm not sure why, but they should.
They think it's adding.
Yeah, they think it's adding maybe. So a lot of little scenarios.